Now I'm going to continue configuration of Eigrp and other routers. I have configured router 1 and 2 and I'm going to router 3. So I go to configuration mode. I start router Eigrp 100 process because I'm going to be 100 AS100 of course, because I want to be in the same AS with the other Eigrp processes. Let's see the IP interfaces in brief and see what interfaces we have here. I have network 10.0.36.3 and I'm going to have this in Eigrp process, and of course the next one is 34.34.34.34. I want it to be in another process, and I'm going to add this in the later sections when I have a configured frame relay configuration. So I'm not going to configure serial interfaces at all, so this is the first the only thing that I'm configuring. Let's go to switch 1, and here I'm going to show IP interfaces in brief, and of course I'm going to pipe the result to have exclude unassigned interfaces. So the only thing that I have here is VLAN 25 on switch 1. So I go to configuration mode. First of all, I should make that IP routing is enabled on this switch, because switches by default do not have IP routing enabled. So let's go to router Eigrp 100 process, and now I can add network 10.0.25.5.0.0.0.0 to Eigrp process number 100, AS number 100, and you can see the adjacency with router 2. Let's go to router 2 and switch 2 and see the IP interfaces in brief and see those with assigned IP addresses, and you can see 2 VLAN IP addresses are here. Again, I should make sure that IP routing is enabled. And now that I have this, I can go to router Eigrp 100 and add these networks 0.16.6 and of course 36.6, and you can see both of them will have neighborship right now. Now that I have neighborship between all routers and every interface is configured as Eigrp interface, I can see the routings populated in routing tables. So show IP route will tell me what route are in my routing table. You can see that from router 1 I can ping routes that are in VLAN 36, and to make sure that this is possible I try 10.0.36.3, and you can see that this is quite doable. So let's see the route that it takes to reach to this destination using trace route, and you can see that it goes through switch 2 and then to router 3, and this is the LAN segment that I have between these routers. Okay, now that I have every router and every interface in Eigrp process, let's see other verification commands here. On router 1, the first thing that I want to see is this, show IP Eigrp interfaces will tell me which interfaces have peers, which interfaces have configured as Eigrp interfaces, and you can see that everything is right here. So let's go to other verification commands, show IP Eigrp topology, and this command will tell you everything about Eigrp. You can see Eigrp database, and in each line you can see one route to one destination network, and you can see it tells me I have one successor. That means I have one route that I can install in routing table, and it has feasibility, and its feasible distance is 28,160. This means that I have assigned this much of metric to this to reach to this network. You can see this is the feasible distance, and any other route that is going to be in this database should be should have a less reported distance than this. And to define what reported distance and feasible distance means, I want to show you one example. Here I have two ways to reach to router 3. Let's see this here. I can go to switch 2 and then to router 3, as I have done here, and I can go through frame relay connection as right to router 3. And based on the metric that I have, I will prefer one of these two routes. For example, if I want to go through switch 2, I may have, for example, distance of 10, for example. And if I want to go through router 3, I may have a distance of 5. So I will prefer the route that has less distance and less metric. So this is the route that I'm going to take. Now if I have, for example, 5 to reach from switch 2 to router 3 and 5 to reach from router 1 to switch 2, this means that switch 2 has reported to me that its distance to router 3 is 5. So if I want to add this route to my database, I should check to see that the reported distance by switch 2, that is 5, is less than or equal to feasible distance that I have. And if this is higher, I will assume that there is gonna be a loop if I choose to add this to my topology table or database. For example, suppose that I have metric of 5 to reach to router 3 using the frame relay. I have metric of, for example, 6 to reach to switch 2, and switch 2 also has a metric of, for example, 6 to reach router 3. So switch 2 will report to me that I have a distance of 6 to reach router 3, and I know that I have another distance of 6 to reach to switch 2. So I add these two, and I will have a metric of 12 to reach to router 3 using the LAN segment. So whenever I fail this route, I will go through this route, and what will help me to have this route in my routing table? This value, that is the reported distance. If this value is less than the value that I had previously as my feasible distance, I will install that in my routing table. And in this case, you can see that this is not true. This is 6 and this is higher than 5. So I will assume that this will have a loop. I will go to this destination through my frame relay network, and I don't want to have a loop and go through other networks. So I won't accept this as a valid metric. So this is the meaning of feasibility here. So I go back to database. I only have one route right now. I'm going to configure frame relay in a moment, and you can see that I will have two routes, and I will prepare one of those because that will have less distance than the other. Now let's check the other verification command. I had show IP route, and the route marked with D will tell me that this is an Eigrp route. And right now in topology table, let's show you a very important feature. Here we see that the route is passive, that is tagged with P, and this is very important to see every route in passive mode. If you see an active route, that means you have lost that route, and you are sending queries to other routers to see if they have a better route, so that they will report me and I will install that route in my table. And normally you cannot find a better route, because if there was a better route, you will have installed it previously. So this is bad to see active routes here. So normally you should see everything tagged with P. So we have show IP Eigrp interfaces, show IP Eigrp neighbors, show IP Eigrp topology, and show IP route as our verification commands. And the last thing that I want to show you is this, show IP protocol. Right now I have everything assigned here. I can see that these interfaces are in my routing process, and I am receiving updates and sending updates to and from these routers. You can see that this is routing information sources. And of course, I haven't changed distance, and I'm going to talk about this whenever I'm talking about redistribution. So we have these verification commands. Make sure that every router has the correct configuration of Eigrp.